Hello. If you want to get a job at a big tech company, you need strong data structures and algorithm skills. But knowing DSA alone isn't enough. You also need to clearly structure your thoughts and communicate your reasoning to the interviewer. That's why in this video I'll run a mock interview based on LeetCode Valid Anagram problem. While it seems simple, this string manipulation problem is a perfect way to demonstrate your mastery of hash maps, character encoding, and space-time complexity trade-offs. This way, you'll not only understand the problem and its solution, but also learn how to explain it confidently during an interview. Let's get started. Hi there, thanks for joining us today. We'll start with the coding task. Are you ready?
Hello, yes, I'm ready.
Great. The problem is saying that you are given two strings. You need to return true if strings are anagrams of each other and false otherwise. An anagram is a string formed by rearranging the letters of a different string, typically using all the original letters exactly once. In short, both strings must have the exact same characters with the exact same frequencies.
Before I jump into the solution, let me restate the problem. I need to check if two strings are composed of the exact same characters in the exact same quantities. If the lengths are different, they can be anagrams. If the lengths are the same, I need to verify the character counts match. Is that correct?
Exactly.
Also, I have a few questions about the inputs. How should we handle empty strings? Technically, two empty strings would be anagrams.
Yeah, good point. In this specific problem, the constraints say the minimum length is 1.
Okay, and what's the maximum possible length for these strings?
The length can go up to 5 times 10 to the 4th characters.
Okay, so 50,000 characters, that means an often squared approach like nested loops to compare every character would be too slow and likely result in time limit exceeded error. The last question, are we only dealing with lowercase English letters or should I account for uppercase spaces or special characters?
Let's assume the strings consist only of lowercase English letters.
Understood. To make sure I got the logic, let's walk through a concrete example. Inputs are string 1 and string 2, where string 2 can be, let's say, red, and string 2 can be car. Both are length 3, however, the first string has a t that the second does not. The output will be false. And if we change here c to t for the car, then the output will be true.
Yes, your understanding is clear. How do you plan to implement this?
The most naive solution would be a brute force approach where we compare every character of the first string against the second, but as I said earlier, that's often squared and very inefficient. Another solution is to use sorting. If we sort both strings alphabetically, we can just compare them directly. If they're identical, they're anagrams. In Python, it looks like this. Via sorted function. This is quite clear and readable, but sorted function uses team sort in Python, so the time complexity here is of n log n. Also because strings are immutable in Python, this creates new strings, so space complexity is of n. It's not constant.
Right, sorting works in this way, but let's assume we need something faster.
To get to linear time, we could create two hash maps based on our strings. For red, it's gonna be R1, A1, and T1. And for tar, it's gonna be T1, A1, and R1. And we just return string 1 equals string 2, which are hash maps. We translate them to hash map first. So this would be time of n and space of n. But since the character said is fixed and small. As you said earlier, we use English alphabet lowercase. We can replace the hash map with a simple integer array of size 26. Array length is 26. And array will be filled with zeros at first, 26 zeros, etc. And then we loop through the first string, and by using the ASCII offset, we can update our counters here. So for example, for the word red, we iterate through this word, and the character R increments its specific index in our array to 1. Then A increments index 0 to 1 because it's the first letter in English alphabet. And T increments also its index to 1 as well. So now I have 3 different slots in my array marked with 1. And then I iterate through the second word or string, doesn't matter, and decrement all the values here. We can achieve this by using ORT function to get the code of our symbols. Let's say our symbol will be X, RAT, and on each iteration we just subtract code of a letter from that X from every character here and put it to our array by this index.
That sounds like the most efficient approach. Let's see the implementation.
Okay, let's write some code. I'm gonna remove this. First, we create a function, is anagram, string1, which is string, string2, which is string. These are inputs, returns bool, and we handle the h case first. If the lengths are different, they can be anagrams. If len string1 doesn't equal len string2, then we return false. Then I can initialize the frequency array. Let's call it count equals 0 multiplied by 26. Now I need to loop through the first string. I'll use OR to get the ASCII value and then subtract of A to normalize the index to 0 to 25 range. Let's iterate first for character in string1. Count by index ort character minus ort A plus equals 1. That's how I increment every value in my array. And now string2. I think instead of just decrementing and checking the whole array at the end, I can probably optimize this loop. If I'm iterating through string1 and I see a character that has a count of 0 in my array, it means string2 has a character that string1 didn't have, or at least it has more of them, so I can return false immediately. Let me write it. For character in string2, if count ort character minus ort A equals 0, yeah, we return false. And after that, we decrement our count like this. Actually, I can create a variable here to follow don't repeat yourself practice. Yeah, here also index like this. And if we iterate through both strings, we should return true because we haven't got any exception here. We haven't got false in here, so we can return true. Okay, I want to make sure I didn't miss anything, so I'll trace this with some example. Let's say string 1 will be red still, and string 2 will be car. So first, the length check sees both are 3, so we move forward. My count array starts with 26 zeros. In the first loop, red, the character R increments its index to 1, then A increments index 0 to 1, and T increments its index to 1. We have 3 indexes with 1 value. Now we move to the second loop. For car, the first character is C. My code calculates the index for C, which is 2. It checks the value at count 2, and C was never in the first string, yeah. So the value is 0, and as it's 0, if condition triggers here, and the function returns false. Yeah, this matches the expected logic, and the time complexity here is linear, and space complexity here is constant of 26, because we have only 26 characters. That means of 1 in big O notation.
That was a solid walkthrough. One last thing. What if the input wasn't limited to lowercase English? What if we had to handle Unicode characters like symbols or different languages?
To handle that, we would return to a standard hashmap approach. I wanted to implement first where the time complexity would be O of n, but the space complexity would shift to O of n as well. But actually, it will be O of k, because if we use Unicode characters, we always know they are restricted for, like, I'm not sure, but it's like 100,000 symbols. So k is the number of unique characters we get from Unicode table.
Exactly. I have no further questions. Great job on both the algorithm and the communication today.
Thank you. It was a pleasure.